Welcome to Turn Right Machine Works. My name is Keith, and today we're starting a new project, and this happens to be a swinging yoke for a bell in a tower that our new customer is Heritage Restoration, and they're Providence, Rhode Island, and they also have a shop over here on the Cape as well. And they brought this to me, and my job on this project is to go ahead and bore and bush this bore on each end of the cradle and each end of the yoke here. Now we're going to go ahead and we're going to dismantle this here. I've got this clamped down to the table upside down, so I got a good hold on it, and then I can grab it with my small crescent wrench, and we're going to try taking this apart without heat and that kind of things, but we are in this area right here to where we can go ahead and we can add a little warmth to it if we need to, and we're going to go ahead and pull this apart. And I think once this nut comes off of here, these pins should have a way to reach in here, and I think there's a nut, a screw, and I think this is a two-piece section here so that you can change these out. I believe that's how they designed it. It kind of looks like two parts right in here. From here, it'll go to a sandblaster, and then they'll go ahead and they'll get it cleaned down to bare metal, and then they'll repaint it, and they'll handle that part of the job. My only job is to go ahead and refurbish the pivot points on this yoke. Alright, we're tightened down here, and we're basically the whole table's letting us hold this, and then we can put our wrench on here, and let's see if we can break this loose. And my little wrench wins again. I'll probably have to hold this all in here because it's like a square head bolt on this other side, and that's what keeps it from rotating. Okay, she's a little firm. Now what we're going to do, we're going to go ahead and we're going to roll her back so we can clear out the debris on the threads. Probably add a little lubricant to it. There's probably a little mushroom going on here as well, but there's a lot of paint that we just broke off of there. Alright, I'm going to go get a little spray lube. We're going to add a little bit on there. Alright, we got it screwed on there a little bit, and we got some rust buster, and we've been squirting it on there. And we rotated this around so we could take our other small crescent and put it right here, and then we'll be able to get this one right on here, and then we're going to go ahead and unscrew that. Alright. Well, at least we can hold the wrenches up here on the top now. Pretty nice nut, oldie. Alright, and the bolt. Now this is what we were looking for to get to the back side, thinking that we'd be able to somehow get that out of there, and it really, I think that's a solid cast there. have to clean this up. I thought that was a split line right there under the paint there, but I think it may be just characteristics to the casting. Alright, we're going to try to get this broke loose without any heat or anything else on this side here too as well. And actually I think we're going to take the needle, we're going to knock a little paint off around here, but not on the threads. We have gained an eighth of an inch just by taking the paint off. I like that, huh? Back and forth a little bit. You can see the paint's actually chipping out there a little bit. I'm going to go ahead and we're going to throw a little bit of this penetrating oil in here. Actually, I don't know why they call it oil, because it almost like evaporates out of here. And I don't like listening to that air hose leak there. Alright. Alright, now that this let go, it's going to make it a little more difficult, I think. But let's see what we can do. Not too bad. You know, for something as old as it is, well, I don't know when the last time it was rebuilt, but I'm sure it was a long time ago. And, you know, the pivots are going to be solid, so we're going to have to either turn those into 4-jar or what. We're going to take some more measurements on it and stuff, and we might make the decision to leave them in the state they're at now. Yeah, they're solid. There's, you know, I thought this line right here that appears to be in here, I thought that was a section that would pop out with some kind of a nut here, and then you could return a straight. So we're going to do some wire wheeling on here with a soft wire wheel over there. We're going to take and mic up our 2 rods, and we're going to make a decision what we're going to do with these here. We're going to do a spark test on them, and we're going to check that out, whether we might build those up and return them, and then bore and bush the females. We'll kind of give us some thought here on what we're actually going to do. And that looks like a washer. Yep. This side didn't have a washer, and one stud or bolt is a little bit longer than the other. Alright, I brought you into the shop here, in the machine shop, and we're going to go over on the Bridgeport there, and we're going to create a center drill hole in the end of the shaft here, and we're going to come back over to the lathe here, and we're going to put a center drill on the other side. We will set up a pair of centers, and we're going to turn these between centers, and that's going to be the first part of the Bell video series here. I'm going to do it in 2 parts here. We'll handle the carrier for the yoke, and do the bore and the bushings in the second part of the series here. Before we get moving into there, I want to make a comment. This is my 300th video, and it's because of you guys out there that it's made it this far in the quantity of videos. And I have a special thanks for Jody at weldingtipsandtricks.com. communication back and forth, and him putting in a plug. Also Mr. Pete and the plugs that's come from him and the viewers that come over from that site. Doug and Kay over at svseeker.com and their videos, and the boat's really looking good, and the keel's really you know, I've built a steel hull vessel. It helped build a steel hull vessel and learned a lot of the trade, and just that same kind of progression that Doug's learning a lot of things. You know, I can remember my first steel hull boat. Also, Jafro and Jafro's Garage, he's communicated back and forth, and you know, he's plugged a few views my way, and we talk about, you know, we throw back a few personal messages back and forth, and you know, we're on top of a couple different subjects there as well. These are, I mean, there's many more out there, and there's forums and comments and things like that that some I don't even see or know about, and I just like to say thank you very much. And all right, let's get on with the video here, and let's get on over to the Bridgeport, and we'll start moving along with this project. All right. We're semi-clean here on the, I mean, we're going to be chucking up the, you know, this got paint and everything else on the side. We got some teeth or engagement. It's almost like a step engagement, so that you can time both sides equally on the yoke there. All right, so we're going to put that down in here, and then we're going to go ahead and tighten up the vise here. Now all we're going to be doing is putting a center drill in there, but we want to locate that center drill hole in the center of the diameter here. So we're going to go ahead and we're going to use our coaxial indicator on this project, and we're going to go ahead, we could put it in the drill chuck, but then that's going to make us bring our table way down and go through a pretty good drop there of our knee, and we only got like 3 inches to go down from where it's at right now, and I like to have a little bit of room for the indicator itself. So we're going to run the indicator in a collet, and this is a 3/8 shank on this one. Alright, so we got the coaxial in here, and I think I'm going to put this other curved tip in here. And that should be enough to reach around. Now, besides this indicator, if you didn't have a coaxial indicator, I also have another way that you can indicate, and this is a regular clamp on that comes on here, and then I would use my Starrett button head, which comes in here, and I'll show you how this fits on here in a second. Alright, and we can indicate. So I'm going to show you 2 indicators here. Might as well go ahead, and we're going to get set up with this one here at first. Alright, now I like to go ahead and put my quill in neutral. Alright, just kind of eyeball. Alright, now I'll bring this in. Alright, now we'll go ahead and pull it out. We're going to bring it down here. We're not going to go right at the edge there. It's got like a little divot right in here. We're going to kind of like go down a little bit right there. Alright, and we're within about 3/4 of the, maybe a little bit more than 3/4 of the dial. I'm not going to say each one of these is a thousandths or a mark, and it could be, this could be millimeters or inches. This is not, you don't need to know whether you're working in millimeters or inches to use a coaxial indicator. You can just look at those as marks. because this travel here is going to be a lot different than the travel out here. Okay, and the distance here is going to be a different ratio than it is from here. So the indicator cannot tell you the true thousandths that it's actually moving. Alright, it actually it gives each line as a half a thousandth of axis offset. But that half a thousandths offset or mark is in relationship to the travel here, this in and out, okay, not in the relationship of the finger all the way out there. There's no way it can be the same. Alright, so we're going to go ahead and we're going to sweep this around. And all you gotta do is get going the right direction. Alright, now we can put this in slow or low. We're going back and forth. Now the reason why it won't get any better than about the 5, and we'll find that is a difference of this length right here, which is 972 and 986. So there's no way that we're going to actually get this to stay on 0 because we are fluctuating in and out as far as the ovalness of wear, because the bell trunnion or yoke only pivots part way. So all the wear is on this side here and not on this side here. Now if you really want to technically get there, we're going to put the other indicator in here just to verify its measurements as well. And before we do that, I'm going to go ahead and I'm going to set my readout here to 0. Alright, now we're going to go ahead and we're going to put this over the spindle here. Alright, back in zero, or neutral. We're going to give it a little bit more of a spring on the plunger here. Alright, now we're going to go ahead and set that at 0. We're going to get our mirror. +5, 0, +5. And we're back to about -1 right there, just because it just happened to move from when we rotated the dial. +5, there's 0, there's +5. Now in reality, I know that the wear is 10 thousandths, right? Pretty close to 10 thousandths, because we measured almost 970 right here, 974. It's out the end 970, but 974 and 970. All right, let's go ahead and go here. We're 980. $985. We'll get 970 down here. $75. $85. In the middle. Okay, it fluctuates a little bit opposites out here at the end and here, so that the alignment has got to be off slightly. All right, we bring this down into the center. Let's go down to the middle of the run here. All right, we get that reading 0 with a little bit of motion on there. Okay, +7, +2, +5. I'm going to say if we get that at +5, +5, and it's like -5, because I think there is like 10 thousandths wear, and we know that it can't wear on the top. So I'm trying to set the top side with this. So our center drill is going to be in the original position of wear, but that would mean we'd be taking 10 off of there. Alright, we brought this one over here just because we want to play with a little bit of what we got in tolerance to make both of them the same if we can. This is 960 and 945. So it shows about the same on the average, about 10 thousandths wear on this bottom side here. You know, do we compensate and shift that over the center line, or do we try to pretend or pick up the original center line and machine the thing totally around to the original center pivot? I don't think it's going to hurt to offset that 5 thousandths, 10 thousandths being exactly in line with each other. So we're going to go ahead and go for the least amount of material needed to clean this. We got 0, +5, 0, +5. Alright, so that's where we're going to call 0 on this one here, and we're going to put the center drill right there. And there again, this is running about 20 thousandths larger than this one right here at this time. We should be able to finish a diameter on both of these just around 15/16 of an inch of diameter, which would be 0.9375. Alright, let's go ahead and we're going to pull our indicator off of here, and we'll set our $2 indicators out of the way over here on the drill press for now, so they're ready for our next one. Alright, and we're going to go ahead and we're going to put our drill chuck back in here. Maybe. Sometimes you put the collet in, sometimes you just got to move the table down. Alright, I just bought, last week I just bought a few center drills there. I've already used up my lifetime supply. There we go. Alright, one down. We're going to switch this out. This one will be ready to go over to the lathe. We're going to go ahead and we're going to take a draw file. We're going to kind of just like, I think there's like a roll burr right there. I just want to take that off before we put it in the 3-jaw to put the center on the other end. Alright, same procedure. And this time, instead of running the coaxial, we're just going to put in the stirrup button head. It just seems to be a quick and easy way. Alright, 0 plus 5, 0 plus 6. Alright. We're going to call that center of this one. We got the same thing. We're basically reading a little bit fatter one way than the other way. We're going to compensate so we can take minimum amount of material off of these. And 5/1000ths up and down variation from its original pivot is not going to matter on ringing the bell. Alright, let's head over to the lathe. Alright, now this is where it may actually be the original diameter right here, but I just want to make sure that it's not a high. Alright, I think I pretty well took that off of there. And now we're trying to grab a hold of this pin so that we can create a center drill hole over here, straight in line with that axis of the shaft. That's why we dialed this one in to get this one here, but we're going to go ahead and we're going to support this by the 3-jaw chuck here. And this is all within the tolerances that we feel are acceptable. Alright, and we can swing this in the carriage. You always want to make sure that your items that you're putting in the chuck are going to clear your carriage and everything else around. And also making sure that you don't have any loose clothing. I wear long sleeves time to time. It's about time to shed this off of here and start wearing short sleeves. But I wear tight cuffs. Alright, no rips, no bags, nothing that can get snagged. Alright. I don't roll a cuff and keep that out here. Those are dangerous. There are a few things there. Everybody will have their own safety in mind, and you should have healthy fear. That's what I call it, healthy fear. And as long as you have that healthy fear, you will stay safe. You can see, of course, I've gained weight, so I actually took my wedding ring off, but I wore my wedding ring a lot. I do pull it off when I feel that it's danger or snagging. It's not a good habit to have it on at all. But I just take it off because I've put on some weight since I quit smoking a couple years back, and it doesn't fit me at all anymore. But I had to get it off of there before it choked my finger right off. I wear these bands. These bands snap and pull off. In fact, this one here is broken a couple times, and I put it back together. I do a lot of things timing and keeping track of time, and I use my watch quite a bit. This will get yanked off. I've had them pulled up. Do not wear leather bands or solid bands. These twist flex, these will break off way before you get drug into anything. Alright. Other than that, let's go ahead and get going on a couple operations here. Alright, we've kind of come in here and to kind of make sure. In fact, actually, I'm at the move you because we want to be in here close because you got to reach over the carriage right here to get the drill in, and I don't want your vision to be taken up, and I can see that this handle's in your way. Alright, I think that's a little better. Alright, now we're going to go ahead and we can get our carriage in here. We're going to go ahead and change our center out to another number 4 center drill. But number 4 is kind of, you know, you want a center drill appropriate for anything that you're doing and your size and everything else, but on the average I find that number 4 is my most commonly used center drill that I use anyhow. Alright, now I'm gonna probably I'm just gonna swing this around 133 here. That's more than enough. I'm gonna kick it up a little bit here, and you want to know what your limit is on. Okay, when you start getting a little motion, see, you can see my light right here, okay, and you can see how that shakes. So you're actually, you know, I don't have this lathe mounted down hard because I don't have any concrete underneath. This is set on plates, and then the plates are set on, I got like a mortar floor in here, okay. This was a homeowner's garage at one time, and pretty sad. I'm getting ready to rebuild the center section of the shop, and then we'll get the lathes moved in, we'll get some good anchored down flooring and things going on. So this is a little bit fast even. This is actually 308 on here, and if we brought this to neutral and we had this brought out here, it'd be 210. We could swing it at 210. I don't see the light moving at all. But you want to be careful when you start swinging things off to the side. Your balance of weight is shifting back and forth, and it's not. You don't want to be causing excess wear and tear on your lathe there. Just kind of a tip there. All right, now we picked the speed. We're going to go ahead and come on in a center drill. This lathe has straight spur gears, and it's pretty noisy. This is one of the noisiest gears, speeds in the lathe itself. And I can tell this is cast. Actually, I shouldn't have put oil on that. The reason why I don't put oil on cast iron, one, most cast iron has got a lubricant of its own, and the other thing is too, it's like magnetizing your bit with the oil, because it just sticks to it and it doesn't fall free, and it disrupts your vision of what you're actually cutting. So that's kind of why I don't put lubricant on cast iron, or ductile iron, I should say. Okay, we've got a nice center drill now at both ends of this part. We're going to slide this back, and we're going to go ahead and put the next one in and do the same thing. I'm going to hit this just a little bit with a file. Come back in, making sure everything is clearing. Alright, back into our gear. Okay, and we can come in, do the same thing. Alright, I'm happy with that. I'm gauging that center hole about 3/4 of the depth of the angle of a number 4. And that width or diameter there is about 1/4 inch. More than adequate strength to support this on each side. Alright, now we're going to set this thing up so that we can run this between centers. Now we have a live center that's going to come in here. It's going to hold this, and we're going to be able to turn this because we want this direction out here. We're going to be able to do that very comfortably with our compound. Alright, so we need a center that's going to hold this perfectly true on this end here. Alright, we're going to, what I like doing, and this one here, I mean, it was quite a bit longer 10 years ago, but I've taken a little bit off of this each time to make this run 100% true. And that's what you do to make it run 100% true, is to go ahead and take a machine cut on your center or your angle. Alright, and I usually turn the diameter and then I turn a little shoulder so that your pressure or your friction of push on this is supported by the front end of your jaws, and you don't have to over tighten or have anything loosen up on your compression of running between centers. You're not really running that hard, but I've seen mishaps and tool pressure and things like that, and I've seen people lose the grip between centers. Most of the time it causes harmonics and you're able to back out of it before you actually fling the part out. But it is good practice, I feel anyhow, to put a shoulder on there. Alright, now that we've chuck on it, and I'm going to go ahead and I'm going to grab an indicator real quick just to show you, because watch, this is the you will always have run out on this because it's not the same anytime you chuck on it. Alright, and I know that my 3-jaw has some run out. So watch this thing make me a liar, but I gotta tighten that post on there. Okay, there you go. And I'm gonna gauge it down here because you want to make sure that that's kind of where you're running there. Alright, and see that we're running 8/1000s, 9/1000s right there. Now I just wanted to show you, basically you can spin this, oh I don't know, what'd you say, I did that about 1/3. Alright, now how close are we? Yeah, it's still about 9. Alright, so we're gonna leave it right there, and we're gonna go ahead and skim that angle. Now that is a 60-degree angle, included angle, and we need to go ahead and take our compound and adjust our compound so that it is 30 off of the straight. And everybody's compound will give you a little 0. Anytime you loosen this, I usually like to go ahead and clean, because it seems like it's one of those areas that doesn't move too much, and you might have Allens and sometimes the things underneath there. Alright, so we're going to go over here, and we have the mark over on this side here, and it does happen to be 30 on our mark. Any number of insert cutters or whatever are good. Now you're placing your cutter in relative to your path coming in here, okay? So you can't, you can have as much as you want, but you want to be able to come up to your chuck. I kind of like still set it almost square, because off of that angle there, it's going to be given a lead angle to here, the face of the bit. Then you come in here, and before I even get started, I kind of make sure that I can get the whole travel. Not quite enough. Alright, should be able to now. Yep. Alright, now I'm going to go ahead, my cutting speed here is about 450 or so. We don't need to put any feet in because we're using a compound. I'm going to touch it. This is 5,000s I'm taking. Cut it all the way up to the end there, even though I only need that much on there, just so I don't have to do it or clear it again next time. And also it leaves it nice and flat for my file. Alright, now I'm going to take a file and dress that. Now, there's comment time to time. The safe and proper way to file on the lathe is to file left hand. By saying left hand, is that the file is in your left hand by the grip, and then you're drawing with the right and going in this direction here, instead of reaching over like you see me do most of the time. This is my habit. I feel comfortable because I've got the clothing, not loose fit clothing, and I have a healthy fear of this. I don't personally want to get wrapped up into this chuck. Alright, if you're learning and you're just starting to get comfortable with the lathe, I suggest you go ahead and get used to doing it left-handed. Alright, it feels awkward. Well, it feels awkward to me because I do it the other way so often. Not, you know, most of the time you're out here and you're working out on the lathe, but when you get up close to the chuck, it's still that's my habit, but not to say that that's a good habit. Okay, it's not a good habit. I usually just take it to where I get a gloss. Okay, I'm going to go ahead and we're going to bring this in. We know that we're going to be riding somewhat like that. Carriage is not going to be allowed any farther than about right there. And we're going to want plenty of travel in here. We're just kind of guessing on it. We might have to push a little bit more than that. All right. So we're gonna go ahead and lock our semi-snug, that tailstock at that position there. Kind of play with it. All right. This is solid, and it doesn't. This spins with a chuck, and this drives, and this is gonna have this is gonna be locked down with its rotation. And on a solid center to a center, you want to put extreme pressure lube. And this extreme pressure lube, anti-scoring, is very, very common here. You can get this in your machinery trade. I go ahead and I put it in both, and people say why? Because you got the live center in the other one. Even though we did as close as we can to it, there is a chance that this axis could be slightly off, and not so much round and round, but the action like a universal joint. It's just good practice. Also too, if you have a lot of times where you switch your part around, it'll automatically have some dabbed in on there. Alright, it's not that it's a big deal, and it's not wasting a whole bunch of high pressure lube in my mind, so I put it in there. Alright, and just enough so that you can start, you know, it almost falls on its own. That's pretty good pressure right there. All right. Now, there are all kinds of dogs. This is very typical dog drive here. I welded on an extension so it could get in here, and I use this a lot in this machine, and that's why I've modified it. Here's another one that it had to work for something that I made. Went ahead and just tack welded a few things, drilled, put a set screw in there, put a couple keys in here just so it had the V type slot on it. Here's an old style right here, and this was 2 square bolts right here and a little tiny V in here, and somebody added that in on that side right there. There's tons of different shapes and styles of dogs, alright? But what we're going to use on this one is a mill clamp bolt, and we're going to go through the center slot right here, and we're going to put the stud over here against this jaw. Alright, let's hope we got enough stuff here to make a stack up here. And I'm going to go ahead and I'm going to bring this up here so you can kind of see what our stack up's going to be, and we're going to be locking against there. Right now I just want to get a flat surface that we can go between here. Okay, that looks pretty good. And we need to sandwich about the same thing over here. We're going to put another washer right here, and we're going to use one of these double nuts. That'll help tighten it, but it will also create a pusher. Okay, this is clearing out here. That looks okay. There. This is doing fine. Alright, let's lock that down. Alright, that rests against the jaw right there. Alright, we're going to go ahead and give it just a little bit more tension so it holds it there. Alright, and a free spin. A little bit more tension. Okay, one thing, you don't want it sloppy. Too much speed. Remember we were talking about getting that down into the 210 range. And actually, okay, I want to hold that back there somehow. And I think just a little bit more pressure is going to be the key to it. Alright, we're going to try to run that. Now we're going to bring you in close so that you can actually see the wear in the trunnion here. And in the center we are almost running perfectly true, and then you can see in here and out here a difference from over the years at sagging or spring. You know, the carriage is not riding exactly right, and the rust and corrosion. Okay, you can see it actually. You can see my finger going up and down right there. and also right there. It's more or less the rust wear on there, but now right here in the center, not as much. Very, very slight. Okay, let's go ahead and I'm going to go ahead and I'm going to use the DNMP here instead of the other style, so that I make sure that I'm reaching in at that point right there. I'm clearing there, and I am going to have to bring this back so that we know that we're starting our cut. Alright, and coming in here, and we're clearing. Alright, we're doing good. Alright, now I'm going to go ahead. This is a negative acting, it is a negative insert, but I want to go ahead and change this out to where I have a scoop or a positive top on here, which I like. It just seems to act more along the positive line there. I'm not going to argue the terminology on it. I just know it's an easier cutting. Got a real slight radius on the nose there too, so when we come into the end here, alright, and we're loaded against the jaw, we're going to give ourselves a fine feed and a great gear. This cut here, we'll wipe it clean and it'll give us a good representation of the highs and lows on it and the wear, and I think we're going to see the pattern curve across. What is over here will almost be the same thing over on there, and it'll hourglass or whatever in the center. Rust scale on the part, so you get that bleeding back up through with the cutting oils that mixes in with that. Alright, this gives you a pretty good idea. This is the top or the non-pressure side, and this was the pressure side, and you can see how much this was worn in here. And this was basically just rusted away, basically from probably the moisture and condensation, you know, sweating or whatever over the years, and the moisture in here. And if there was any oil or whatever, it was rubbing in on there. Now we averaged it out side to side, so that's why you see here and here we're not touching at all. And it's almost even here and here and here and here, side to side. Pretty good little valley right in there. Now this is the arm that actually had the pull cable or the action cable on the bell. Alright, now let's go ahead and let's check our diameter here. Alright, our diameter here is 955 right now. And in that low area it's like 945. Across here 945. And across there 940. So we're shooting for like 15/16. We're not going to be far off. But we do have one area right here that's, you know, like 939. So it's going to be probably just slightly smaller than 15/16. But we'll, you know, we'll be able to keep it pretty close to that. This is still going to be better than well building this up and taking a chance on the heat disrupting between this base material here that was casted in with that steel there, or the iron there. Alright, we're going to go ahead, we're just going to sneak up on it. We're going to take another 5 thousandths here. Alright, we just mic'd this up across here, and we're at 935, maybe just a skosh under. Alright, and this is the pressure side right here. We do have one little holiday right in there, and I've mic'd across there, and we're only getting like one. There's a gouge right there, a ding, and we're not going to worry about cleaning that. Now we're coming up here. Now we're at the top. This, when it's in position right there, this never has pressure against it. This is always to the upper side, and that's why it's rusted and pitted in that area, because moisture is there and it never sitting tight against anything, and it's always an air gap. Alright, but from here to this side here, you know, more than 3/4 of the way around, we got 100% clean up there. Now there is a little shadow right there. We're going to go ahead and just make one more skim cut across here. I'd almost leave it just like this, but we're going to make one more skim cut, and if we can pick up just a little bit on each side of there, we're going to call it done. We're not going to worry about cleaning this up 100%, but I think it's well worth, because we mic'd this across here, and we're at like 394, I mean, excuse me, 934. And this is with the anvil there. So we're going to go ahead and we're going to give it 2.5 thousandths per side. It's going to be our next cut. So we touched and 2.5 thousandths. Alright, there's still a couple little bumps down in there. We're not going to clean it any more than that. We're going to call that good. Now this is, you know, these are what I call witness marks, that we didn't actually take too much off of the diameter, but we're not trying to prove anything by that. We just want minimum amount off of here to make round diameters so that we can make the bushings fit there. Now actually we only took about 1 thousandths off of this from what I touched. So we're looking at 934. And we're going to go ahead and we're going to chamfer this outside edge. So we just change out this to our other direction. From our left to our right hand. Our right hand to our left hand. Just a real small amount. We don't need much more than just to break that. Alright, now we got some emery strip. But before we do emery strip, I like to lay down a cover in here. And we also make sure that that cover is going to clear the part so we don't snag it and have it come flying around on us. Okay. Alright, I'm happy with that trunnion right there. And $934 thousandths. We're going to go ahead and set up the next one. Okay, and just because we've had grit and stuff around here, we're going to apply new pressure lube to 2 new clean centers. Alright, and the same setup. The way we kind of broke it down, we just put that on that side and we pull this nut off of here. Alright, and give it enough tension, lock it down. We pull out our cover for sanding. Alright, and just because it's this exact same part, we want to check all of our travel distances, the same thing. Alright, coming in, we're going to be pretty close to there. What do we got? We're clear. Okay, we got almost a handful that we can put in there on width. This comes in here. Alright, we're looking good. Alright, let's make our first pass. We're just going to touch. Now this is the fatter of the two. We're going to go ahead and take 10 thousandths on this first cut here. This one will probably clean up better than the other one, but it should be pretty close to the same. You can see more wobble in here than you can in the middle. Okay, a little bit of a spiral type. You know, you can see this leading off here and then this leading off over here. Alright, but it does have a light ring all the way around there where it was rubbing. Now this is the top, this is the non-pressure side. We have the same thing here. We are almost all the way around. Now this is the idler side. The other side actually had the bar and is the control of the bell. So it had a little bit different forces than this side here. Now let's see how, you know, that's 10 thousandths off of there, and we're reading 967. You know, quite a bit bigger. All right, so we can go ahead and we're gonna go ahead and take another 10. I think, but you know, we got that much room to play. So you got 60 to 40 there. We're gonna try at least another 10. Still left a little bit right there in that little valley right there. Now it looks like we're cutting pretty much all the way around. Alright, just a couple little shadows there, not bad. A little hollow right there. Alright, now what diameter are we? We are 945. Alright, we're going to switch this out. We're going to kiss that edge right there, a little paper polish, and both of the trunnions are done. Okay, now let's go ahead and, if you're wondering, it didn't bite me. Alright, we've got our 2 mills kind of cleared out. We got this set up. Tomorrow morning we're going to start in on part 2 of the video series here. We did complete both trunnions, and I'm kind of just looking in here. We got about 200 thousandths up and down clearance, and probably side to side about 1/8 of an inch there. We're going to go ahead and make 2 oil-like bushings that are going to set in there. They will lock in with an anti-rotation pin. And we're going to be drilling in here and putting in a zerk and grease fitting instead of the little oil cup that is actually filled up with paint. We'll get a good close look at that as we needle gun the 1/4 inch in some places thickness of paint there, and we'll be getting to that. Alright, we'll turn the bronze bushing in there, and the rest of the millwork will be a combination of the K&T and the Bridgeport. Alright, till tomorrow, get her done.